All right, so we're going to finish off 2.1. I looked at some of your books. This section, the grids are hard to see, right? Yeah. Okay. Okay, so you can see a little outline. So tangent, what are the formulas again? So, ka, toa. So what does tangent work with? Opposite and adjacent, okay? So for the 5/6, which one's which? 5 is the op, 6 is the adjacent. Okay, so put a point on the grid, mark it A. Go 6 over. 1, 2, 3, 4, 5, 6. That's adjacent. Now go straight up, 5. 1, 2, 3, 4, 5. Connect that, make the right angle triangle. Okay. Now how would you solve for that angle A? Do you guys remember? What do you do if the angle is unknown? It's up here. Do you remember this? Second tangent. And then on some calculators, you need to put a bracket, opposite divided by adjacent bracket like this. And you have to be in the degree mode. Your calculator has to be in the degree mode. Okay, so for this one, second tangent, bracket, 5 divided by 6, and that will calculate A. So it says 39.8, round that up to 40 degrees. Because degrees are pretty accurate. If you ever look at degrees, they're pretty accurate. So don't worry about the decimal. So A is 40. So if that's 40, what's this one up here in the other corner? What's this one here? 50. If the one's 40, the other one's 50. They have to add up to 90. Okay. Now this one over here, what's the difference between these two questions? Let's contrast. Let's compare. This is 5/6. This is 0.2. What's the difference? One is a fraction, the other is a decimal. Are decimals and fractions related? Yes, they're just ratios. Decimals are just ratios. Okay? So what is this as a fraction? 0.2. Is that a tenth? Don't skip a step. Is that a tenth? Is that 2 a tenth? So it's 2 out of 10. 2 out of 10 reduces to 1/5. So this formula, this equation is just tangent A equals the ratio 1/5. Okay, so trigonometry is always going to look like this. Okay, I'll use my pointer. On the left side, you have sine, cos, or tan with an angle. And then on the other side, a ratio. Ratios can also be decimals. Okay? If you don't know the angle, how do you solve it? Second function. Okay? How do we draw this thing? Pick a spot. Which one's the adjacent? 5, right? So you go 5 over. 1, 2, 3, 4, 5. And then you got to go 1 up. So this angle is going to be a little bit smaller, obviously. See how this one's 40 degrees? And then this one over here, we should expect it to be smaller because the up part is small and the over part is quite large compared to the up part. So this should be a small angle. And when you go second function tangent of 1 divided by 5, what do you get? Is it small like we expected? 11.3. So we can just round that to 11. Okay? And if this one's 11 down in the corner, the other one is 90 minus 11, which would be 79. So that's this angle right there. All right, so there's a lot going on right now. There's SOHCAHTOA, there's labeling triangles, there's solving for angles, okay? So hopefully you don't feel too overwhelmed right now. The next one says determine the tan ratio. So all we need is a ratio, okay? We don't need an angle. They're not asking you for the angle. So you don't have to do second function tan here. You just need to find the ratio, okay, for the acute angles. How many acute angles are there? There's two of them. You got to work with D and you got to work with F. And do we care about E? No. So here's what we do. Mark angle D. Okay, it's marked. Straight across, that's our op. Find the 90, mark that. Straight across that is the hypotenuse. That means 4 has to be the adjacent. So tangent of D is equal to, what's the tangent of an angle? Well, the formula says it's the opposite divided by the adjacent. So 3 dividing 4. When it says determine the tan ratio, that's what we're looking for. This is a multiple choice question. Determine the ratio. That's it. Okay? All right. Now let's work with F. Okay? Tangent of F. Abdur Rafi knows this one because he did his homework in block 1. If this one's 3 over 4, this one should be 4 over 3. Why? Now we're working with this angle up in the top here. So straight across F, now 4 becomes the opposite. And 3 is the adjacent. Hyphen always stays the same. So the opposite and the adjacent just switch, which means now tangent of F is 4 over 3. And if they're asking for to determine the ratio, that's all they care about. Just the ratio. All right, so for this weekend, where's the homework? Oh, is there one more? Is this what you have on your page? I don't think so. Does it say 3? I don't think it says 3 to 6. It says something else. 3 to 5, right? So just make sure at the bottom of your page, make sure you do what it says this weekend and tonight. Okay? Is this question on your page? Okay, let's do that. A support cable is anchored to the ground 5 meters from a telephone pole. Okay, what the heck is that? What's a telephone pole? And remember, you're just drawing a triangle. You're just drawing this every time. The right angle triangle. So where's the pole? Straight up and down, the hypotenuse, or the left and right? So the pole goes up and down, so that's 5. Or no, I screwed that up. Geez, your teacher needs more coffee. Okay, I'll draw this a little bit nicer. Straight up and down, straight across. Oh, I missed again. Okay. Let's be very careful with what we read. A cable is anchored to the ground 5 meters from a telephone pole. So is that this? That's the ground level. The cable is 19 meters long. So is that which one's the height or the up down? Yeah. Then it says what angle to the nearest degree does the cable make with the ground? So they want this one here. They want theta right there. Okay, so according to that theta, okay, we have labels. According to this theta here down in the corner, if I go straight across, this is my op. Find the 90, go straight across, this is my hype. So 5 is adjacent. Now this is the tangent section in the notes. So I don't know why this question's in here. This is cosine. Why is it cosine? Yeah, you have adjacent, so check on adjacent. And you have hypotenuse, so check on hypotenuse. So it has to be cosine, not tangent. Okay, so we in fact have to use cosine. Cosine theta is equal to, what's the ratio for the cosine of this theta? A over the h is 5 over 19. If you know the ratio and you want an angle, what function do you have to perform? Second function cos. And then you input in your calculator the ratio, and it will output the angle. So second cos 5 dividing 19. 74.7. So 75 degrees. Does 75 degrees make sense? Well, it's a really long cable compared to how far across the overness is. So check this out. Say there's the pole, and let's say the overness was really tiny. What can you say about this angle? It's going to be large, close to 90. What if your telephone pole was like this, and the cable is anchored way, 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 way over there? Then this angle here is going to be smaller. Does that make sense? And then the sine, cos, and tan will help you solve for all triangles every time. It's like perfect, okay? It's like always works, okay? For every right angle triangle. So make sure you solve that homework on your own time. And I'll give you some time today. Okay, so going into the next section. 2.2, problem solving using the tan ratio. Do you need a book? Where's your book? Okay, so what does this say? Your calculator is your best friend when it comes to trigonometry. To find an unknown side when you have an angle and a side, u. Okay. Okay, so for number 1, you're going to label. Okay, so you need your op, your adj, and your hype. So this section is going to be a little different. Now you need to find an unknown side. That's different from last section. What were we trying to find last section? An unknown angle. So now we're trying to find an unknown side. Okay? So first thing you're going to do is you're going to label. And then number 2, you're going to set up the appropriate equation. And what do I mean by appropriate? What do I mean by appropriate? So like if they give you stuff for opposite and adjacent, and you know absolutely nothing about the hypotenuse, can you use either of sine or cos? You have to use tangent. What if they give you the hypotenuse and you have to use the hypotenuse? Can you use tangent? No. So it's all about making the right choice of SOHCAHTOA. So setting up the appropriate equation. And then number 3, cross multiply. That's it. That's how we solve trig. Trig is just cross multiplication. So students typically find trigonometry one of the easier units, and the class average is always higher in the trigonometry unit. All right, I'm going to hold off on calculator keystrokes for now until we actually do a problem. So let's go work down in the problems down below. Okay, is this what you have on the bottom there? Okay. So do you see how they gave us one of the acute angles? 23, 56, 16, and 42. So that's the one we're going to use. Okay. You could solve for the other acute angle if you want, but what's the point? Just use the one that they're going to give you. Okay. So let's work on this step by step. Mark it and label. And I always do opposite and hypotenuse because those are easy. Hypotenuse is always directly across the 90-degree angle, and the opposite is always directly across the angle you intend to work with. Then that forces the third side to be the adjacent. Then I play a game of what I want and what I know. And I'll use a highlighter for this. What do I know? I know 12 is op. So I know op. Okay, and just jot this down on the side. So, ga, noa. It's also on your formula sheet if you just want to use your formula sheet. Okay, so see how I know op? So which ones can I use? Sine and tan. So right away I know I can't use cos. Okay, now keep playing the game. What do I want? I want x, which happens to be adjacent. So which one, sine or tan, does adjacent as well? See it? Tan does O and A. So for that question, I have to use tangent. And I write it like this. Here's my appropriate equation. Tan 23 equals opposites over adjacent 12 over x. Now what some people do is they put the tangent or the sine or the cos or whatever it is over a 1. And then that helps you with your cross multiplication. Do you guys remember how to cross multiply? Can I just do one just for practice? Just by looking at this, what does x have to be? What number? 6. Why 6? It's just proportions, right? Half equals 3 out of something has to be half. This has to be a 6. Okay, so for every cross multiplication question, you always divide the thing across x. So we're going to end up dividing by 1 here. And the other 2 you times. So it's like times those, divide the thing across x, make the fish. Times those 2, divide the 1 across x. So it's just 3 times 2 over 1 equals x. Times the 2 that are just numbers, divide the thing across x. And 3 times 2 is 6. Okay? So back to our original problem. What do we times? 1 times 12 and divide out tan 23. Okay? So it's 12 times 1 over tan 23 equals x. Now tangent is a function. You guys don't probably know what functions are quite yet. Okay? A function has an input and an output, and we'll learn this later in the semester. So for tangent, in order for you to get a number, you have to input an angle. So tangent bracket 23 bracket is just a number. Okay? You cannot just put 23 And you cannot just put tangent with nothing. Has to be tangent and then angle, okay? So what is 12 times 1, obviously just 12, divided by tan 23? 28.3 to 1 decimal place. Is that an angle or a side? It's a side. So if they gave you centimeters, you put centimeters. If they gave you feet, you put feet. Okay? Let's do the one underneath. Same process. Mark it and label. X is my op. 12 is my adjacent. What do I want? Op. What do I have? Adj. Which one does op and adj? Towa. Op, adj. It's tangent. What goes next to the tangent? The angle. Put it over a 1. On the other side, you have the ratio. X over 12. Now we cross multiply. You always divide the thing across x times the other two things. So it's tangent 16 times 12 all over 1. Do you need that 1? No, but whatever. We'll put it there just to be sure. Equals x. So what's tangent 16 times 12? 3.4 centimeter. Is anybody getting something completely different when they type it in? And if you are, it's probably because you're in the wrong mode, degree mode. You have to be in degree mode. All right, let's do the ones on the side now. All right, mark 56. Are these all tangent? Yeah, because they don't give any hypes. So these are all tangent. Because see how they didn't give any information about the hypotenuse in any 4 of these problems? Okay, so tangent 56, put it over a 1. What's the other side going to be? Opposite over adjacent. Which one's opposite 56? X over 24. To solve this one, you times tangent 56 by 24 and divide 1, and you get x. 35.6. Now the one on the bottom, tangent 42 over 1, what does it equal? Opposite over adjacent would be x over 19. Good. X is across 42, so x is opposite. 19 is right next to 42. 19 is adjacent. Cross multiply. Always divide the thing across x. Tan 42 times 19 all over 1 equals x. $17.1 centimeter equals x. 17.1. So how do you guys feel about trig so far? Not that bad, right? Yeah, it's all about picking the right function. So the setup is crucial. You spend 5 seconds solving, you spend a couple minutes setting up. Okay, so it's more about the setup than the actual execution. Because if you don't set it up properly, you're toast. Okay? Anybody can solve a trig question. They're just cross multiplication. But it's the setup that is challenging. I feel like we'll come back to this. What does that say? Okay, so these are your usual suspects. That's what these are. I'll put that here. Usual suspects. You know what that means? These are the guys that always come up. So like if there's a crime, the police will always go to the usual guys. Who are the usual guys that screw this up? So these are the questions that you'll most typically see. Okay, the ladder question. When you lean a ladder against a wall, what does it look like? Looks like this, right? There's your ladder. So the ladder is the hypotenuse. And they will say, how high up? If they ask how high up, what are they looking for? This side. If they say how far from the wall, then they're looking for this one. Or if they say, what is the length of the ladder? Then it's this. Okay, so that's how they'll change that up. What's the next one? Shadow. Okay, so how do shadows work? I'll draw me. This is me. There's me right there. So sun shining, yeah. Some sun rays are coming at you. Getting my tan on. What happens? Where? What color should my shadow be? Black? Gray. I don't have a gray. Ooh, there's custom. Oh. I don't know how to get gray. Oh, I found gray somehow. Okay. There's my shadow. Okay, back to, let's be serious here. Okay. The shadow would be on the ground, clearly. Okay? And then you probably have to use the height of the person. And then you get this right angle triangle like this. So there's the shadow question. They would say, how tall is the person creating the shadow? Then you search for the up-down. They'd say, what's the length of the shadow? Okay, then you'd search for the left-right. I don't think they would ask for the hypotenuse in that situation. Okay, kite problems. How do you fly a kite? Okay, let's draw my girlfriend this time. Those are her bow ties. I don't know how to draw a girl. Whatever, go like this. She looks funny. That's my girlfriend. She's crazy. Has a big mouth. Ah! So she flies her kite like this. Okay? So there's her kite. It's got a tiny little tip on the end. So there's her kite. If we were to make a triangle from this, like approximate this kite, here, I'll use a different color. Then the kite's length would be the hypotenuse. The up-down from the ground, and then the overness. Okay? So the kite, the string attached to the kite would be the hypotenuse. The height above the ground is the up-down, and then the distance from the tip of the kite to the ground to the person, this is the overness here, the adjacent. Okay, what's the next one? Angle of elevation, angle of depression. Okay, so not to like ridicule depression or anything, but like when you're depressed, how do you feel? You feel down, right? So when you see this depression, I want you to think you're down. When you're doing angle of elevation, you're feeling up. You feel good. You're elevated. You're like, woo, I'm elevated, right? Okay. So I wish this line wasn't there in between. But let's just draw over it like it's not even there. Okay, so here's a cliff. And I'm thinking about doing something because I'm depressed. Just kidding. Okay. There's some water. There's a boat. When you're looking down at that boat, where's your line of sight? It's all about the line of sight. So just draw a line that connects the person's line of sight to the boat. Okay? Where's the angle of depression? How do you measure it? And it's kind of weird at first. It's all about this horizontal line. It's measured from a horizontal. Okay? So here's two horizontal lines. This is actually the angle of depression. It's the same as this one here, the angle of elevation. So if you were in the boat looking up, you would measure it from the ground, right? See how it goes up from the ground? And I'll put, instead of ground, I'll put a horizontal. Up from the horizontal. And then if you remember parallel lines and the transversal cutting through, the angle down here is equal to this angle up here. So those two angles are equal. And this one is measured down from the horizontal. Okay? So this one's the angle of depression. This one's the angle of elevation. And they are equal. They are equal to each other. So it's all about the line of sight. If you're in the boat looking up at the person, it's measured from the ground. If you're on the cliff looking down at the boat, it's measured from this imaginary horizontal, from like your head or your eyes. Measures down. Okay? All right. Draw a right angle triangle. Okay, tell me folks, where's the angle of elevation? Right here. Okay, why is that the angle of elevation? Because it's going on the ground and then you're looking up. So how would you draw this? From the ground going up. Angle of elevation. I'll take it all. All right. Now, I'm in a red pen here, so you look angry. From the side going over, not the angle of depression. People always think that's the angle of depression. It is not. That is the most common mistake. So on a test, I'll give you zero picture, just words. It will say the angle of depression is blah, the side is blah, and then you have to draw the picture. If you don't know what an angle of depression is, you have no chance on the problem. And you sit there and you're upset because you don't remember. These two things you absolutely need to know. So if they ever give you the angle of depression, all you need to do is draw the angle of elevation, because they're identical. In order to find the angle of depression, what would you do? You would draw in a horizontal line like this, and you would draw down from the horizontal. That's the angle of depression. Okay? And those two things are the same. They are the same thing. So if on a test I give you angle of depression, put that in the angle of elevation. It's the same. Please remember this. This is like every semester. This is not the angle of depression, okay? If a tower is 320 meters tall, okay, at the bottom of your page, I'm sorry if you wrote on this section. Go ahead and do this problem now. If a tower is 320 meters high, draw a tower. There's your tower. It is 320 meters tall. How long is the shadow when the sun is 36 degrees above the horizon? Okay, so like always, you're going to sketch in some right-angled triangle. Right angle there. What is this 36 degrees above the horizon? Is that a depression or elevation, or is it the same? Uh-oh, what just happened? I touched something I wasn't supposed to touch. There it is. Okay, back to normal. 36 degrees above the horizon. Above would be like, above the horizon. So that's 36. Then it says, how long is the shadow? The shadow would be here. Need some labels. 320 needs a label. Shadow needs a label. 320 is opposite 36. Shadow is adjacent 36. And hypotenuse, I don't know anything about the hypotenuse. Which formula has nothing to do with the hypotenuse? Tangent. Remember, SOHCAHTOA. Okay? Nothing to do with hypotenuse. Cross those ones out. It has to be tangent. What do I put next to tangent? The angle. Put it over a 1. Opposite on top, adjacent on the bottom. 320 over shadow. How do I solve for shadow? Ooh. You always times the two numbers and divide the thing across the unknown. Maybe you want to write this down. Always divide the term across the unknown. So it'll be 320 times 1 dividing tan 36 equals shadow. What did you guys get? 440? $440? Okay. 2 more questions and then it's time for your homework. Okay, a cliff in Ireland, 120 meters above the ocean. Tourist looks down at a boat, 200 meters away from the base of a cliff. What's the angle of depression that the tourist sees the boat at? Cliff. Boat. Tourist. Line of sight to the boat. The right angle is the cliff with the water. The line of sight is the hypotenuse. The cliff is the opposite to this angle of elevation. The distance from the base of the cliff to the boat is the adjacent. They asked for what? What's the goal of this question? The angle of depression. So if I solve for the angle of elevation, I get the angle of depression for free. All you gotta do is solve for the angle of elevation. Okay, let's put in what I know. Where does the 120 meters go? Up? Because it's the above the ocean, the cliff. Where does the 200 go? Adjacent, because it's from the base of the cliff to the boat. Okay, so again, I don't know anything about the hypotenuse. So I have to use tangent. I don't know the angle, so I have to just put a variable there, and we use theta for that. And then on the opposite divided by the adjacent, I put 120 over 200. What do we do when we solve for angles? The second function. You only use the second function for solving for angles. If you're solving for a side, you just use the regular function. So theta is tangent inverse 120 over 200. That little -1 in the power, it's not actually a power. It's just a symbol for inverse. The opposite. It's like the opposite of tan. What do you guys get? 120 dividing 200. 31. And it's degrees because it's angle. Okay? So that equals angle of depression. 31. Can I just show you guys something quick? Like just math related. Say you had something like this. X squared equals 25. How would you solve this? Like if it's Pythagorean theorem. What's the opposite of squaring? U square root. So you get like 5. Okay? So what if you have this? Tangent x equals 120 over 200. Well, what's the opposite of tangent? Yeah, second function tangent or inverse tangent. Okay? And then you have to just put in the, so like you have to put in the ratio and it will output the angle. Okay? So it's similar. It's like, think about this one. 5x equals 25. How do you solve for x? You have to do the opposite of timesing 5, which is dividing 5. So what's the opposite of tangent? second function tangent. Okay? So that's that. Okay. Shadow question, and then you can do your assignment. The sun makes a 58-degree angle of inclination with the ground. Height of a tree, 8-meter shadow. Ooh, this one's fun. A tree. Looks like a piece of broccoli. Here's my landscape. Try and make this 3D. There's no point. I'll make it 2D. Okay. Okay, so they're asking for the height of the tree. So let's call that h. What is h? Where does the 58 degrees go? Up from the horizontal. What height of tree would an 8-meter shadow? Where's the shadow going to be? On the ground. So there's the shadow, and it's worth 8 meters. See how they told us nothing about the height? So again, it's tangent. What goes next to tangent? The angle. It's solving for a side, so I like to put it over 1. Opposite is h, shadow, the adjacent is 8. I'll just jot that in for you guys. H is op, shadow is adj. Now I cross multiply. Tan 58 times 8 all over 1 is equal to h. .8 meters equals h. So you have 2 assignments to work on. You got 20 minutes in the class right now, plus you have the weekend. And then you'll have another assignment tomorrow. Okay? And we'll do the daily quiz for this section tomorrow.